All right, you guys, time for a second podcast. I'm Steve Ye,
I'm Dang Tung.
And I'm Ariana.
And Mrs. Kato.
and this is on isotopic topic notation and atomic mass, and it is on chapter 4.
Alright, let's get started.
Atomic number is the number of protons in the nucleus of an atom. It is protons are positive, and the atomic number determines the atom.
And then the mass number is the total number of protons plus the total number of neutrons in an atom. So to find the neutrons, you would do the mass number minus atomic number.
Okay.
Complete symbols. Mass number is usually in the top left corner. It is always in the top left corner. And it is the number of protons plus neutrons. Protons plus neutrons. Atomic number, bottom left corner. And it is the number of protons.
Okay. You want to do the charge, Ariana?
Sure, the charge is in the topper right-hand corner, right-hand corner, and it is either positive, negative, or neutral.
Okay, great. Let's do a couple of practices.
Okay, this is a bromine, and then number of protons. Where would that be?
In the bottom
We're
left-hand corner.
so nerdy.
Yay! Okay, so the number of protons is number 35.
Alright. What about, how do I find the number of neutrons?
You would subtract the mass number by the atomic number. And you would get 45.
Yeah! There we go,
Yay!
Ding
So 80 minus 35 equals 45. Yay! Okay, now, how do I find the number of electrons?
Well, since in the upper right-hand corner, there is no charge there, it means it's neutral. That means that the same number of electrons equals the same number of protons. So that means there is 35 electrons.
Great. And where are the atomic numbers again?
Atomic number is on the bottom left-hand corner.
So again, 35.
Mass number is upper left hand corner.
And again, 80. Alright, now let's do something with the charge. An element has an atomic number of 34 and a mass number of 78 and a charge of negative 2. So now, how many number of protons do I have?
Number of protons is 34.
34 because it is the same as the atomic number.
Number of neutrons would be
44.
Get some math.
44 neutrons. Alright, okay, now, how many electrons is that? Well, I have a charge of negative 2, which means that I have more protons or more electrons?
Electrons.
More electrons. How many more electrons?
2.
So I have how many electrons?
36.
36. And the complete symbol is going to be, well, actually, what element am I talking about? If it is 34.
You are talking about SE.
Se. Selenium. Alright. And in the bottom left-hand corner, I have
34.
34. And in the upper left-hand corner, I have
78.
78. Am I done?
No,
Nope.
you have a negative 2 charge.
I have a negative 2 charge, and now I'm done. Great. And then, okay, now let's talk about isotopes. The isotopes are varieties in an element introducing the uranium twins.
We are both element 92, but he's heavier.
That's because you're more active. Funny.
Isotopes are atoms of the same element having different number of neutrons and different mass numbers.
Great. And we can do a couple more practices like we did in class. So if you felt like you were very confident in this, you can skip the next about 2 minutes. So you may ask, how heavy is oxygen? And my answer would be it depends, because there are different kinds of oxygen isotopes. And so we need to, so when we take oxygen, we don't know which oxygen we're getting. So what we're going to do is use the average atomic mass of the oxygen or whatever element that we have. So average atomic mass is based on the abundance or the percentage of each variety of the element. So the the number that you see in the bottom of the periodic table, this is actually the average atomic mass, which we can call just atomic mass. So remember that this is different from the mass number, which is the number of protons and neutrons, and the atomic number, which is the number of protons. So this is protons, this is number of protons plus neutrons, and this is the average atomic mass, or the atomic mass, which is counting how much of each isotope we have. So let's review some things before I go on to calculating the atomic mass. Atomic mass unit is 1 AMU, and is defined as 1/12 of the mass of carbon-12. So if you had 1 mole of atom, it would be measured in grams. So the number that you see here, if you have 1 atom of boron, we don't know which isotope it is, so we're going to say it's that many AMU in AMU. However, if I had 1 mole of the boron, it would weigh 10.8 grams, right? Grams. Alright, so in order to calculate the atomic mass, we multiply the atomic mass of each isotope by its abundance, then add the results together. So let's try a couple. Here is my isotope carbon-12, carbon-13, and carbon-14. And what we're going to do is take the mass of carbon-12, which is 12 AMU, and then multiply by its abundance, and then get whatever that number is, which is 11.87 AMU. And then you're going to take the 13 and multiply by the 1.11, and then 14 times by, let's say, 0.01. And then what you're going to do is whatever those numbers are, this number, with whatever that number was, and add them all together, and then you are going to get 12.01, which is in the bottom of your periodic table. Likewise, here is a slightly different kind of example. We have neon, and I put neon 12 actually has a mass of 19.99, which is close enough to 20. However, it's 19.99, and this because of the slight difference in the masses that you see over here and the masses that you see over here is due to this effect called the mass defect effect, which we're going to go into when we go into nuclear chem. So let's just hold off on that and then just continue on. This is a mass of neon 20, and we're going to multiply these two numbers together and get a number. We're going to multiply the mass times by its percentage and get a number. We're going to multiply by the mass times by its abundance, and we're going to get the number, and we're going to add these numbers together and then tell me what you get and confirm it with the periodic table to see if you are right. Over here I don't tell you what the element is, so your job is to find out what this element is. You're going to multiply its mass times by its abundance, mass times by its abundance, add those two numbers together, find the atomic mass, and then looking at the periodic table, find me the element. And I will ask you about that in class if I get a chance. Or you can ask me about it if you have any questions regarding which atom this is. Alright, so let's review the periodic table a little bit. The periodic table has elements grouped based on its set of repeating properties. It allows you to easily compare the properties of one element to another. So let's take a look at, let's get some terms down. The horizontal rows are called a period, and each column is a group, and a group or a family, otherwise called family, have similar properties. Oh, you know what? I have it right here. Elements in a group have similar chemical properties as well as physical properties. And that is it for this podcast. If you have any questions, please come to me during tutorial.